This is Honors Geometry. Note section 14.3, we're finding areas of trapezoids, kites, and rhombi. To remind you what a trapezoid is, a trapezoid has two bases, and in this state of Nevada, it's kind of like a trapezoid. Make those a little bit thicker. Once again, those are called bases. We got base 1, base 2. The two sides that are not parallel, those are called legs. So we got leg 1, leg 2. And if you remember, a median of a trapezoid goes through the midpoint of the two legs and is parallel to the bases. Bases are parallel, median's parallel to that as well. And if you also recall, the length of the median, once again, this is the median, it's the average of the bases. So it's 1/2 the sum of the two different bases. It's all old stuff. Notice in the formula for the area of a trapezoid, it's 1/2 times the sum of the bases, which is also what we call the median. So the area of a trapezoid is the median times the height. It's the median length, it's the average length, times the height. Height is perpendicular to the bases, and in this particular example that you see here of Nevada, sure looks like the height is also the length of a leg. So looking at this picture, if we wanted to find the approximate area of Nevada, if it was a trapezoid, it's not exactly, but it's close. We take half the sum of the bases times the height. We are saying the bases are 205 miles and 511 miles, and the height, which is this leg here, would be 309 miles. We would get half of 716 times 309. That would give us an area of 110,600 double deuce square miles. Let's check out some more examples. Find the area of this trapezoid. Formula for the area of a trapezoid is 1/2 of the sum of the bases times the height. So in this case, this is a base and this is a base. So we'll call this B1 and B2. You could call it B2 and B1, it doesn't matter. The height is perpendicular to the bases. We don't know what that is. Is there a way to figure that out? Well, there sure is. If you take this triangle, it's a right triangle. We know an angle and a side. So that means we can use trig to figure out what this height is. Using our acute angle of 42 degrees, we have the opposite leg and hypotenuse, so we're going to use sine. Sine of 42 degrees is the opposite leg over the hypotenuse. If you multiply both sides by 11, you're going to get 11 times sine of 42 degrees equals h. Put that in your handy dandy, your calculator, you're going to get 7.36 is the approximate height. So continuing to find this area, we add the bases of 8 and 17, multiply it by the height, which is about 7.36. That's going to be half of 25 times 7.36. Using a calculator, I got that is 92. And the units were miles, 92 square miles. Alrighty, let's check out number 2. Find the height of the trapezoid. We know the area, we know the bases. Well, the area of a trapezoid is half the sum of the bases times the height. We know the area is 51.1. We know the bases are 3.5 and 11.1. And we don't know the height, which in the picture, it's an x, so I'm going to use an x. So that would be 51.1 equals a half. 3.5 plus 11.1 is 14.6. Half of 14.6 is 7.3. If you divide both sides by 7.3 using the division property of equality for all numbers .io, you're going to get 7 exactly centimeters is what x is, the height, if you will. Let's look at kites and rhombuses, which is really just rhombi. Kite. First of all, what is a kite? Kite's a quadrilateral that has two pair of sides the same length, and those two sides are adjacent to each other. A kite, its diagonals will be perpendicular to each other, and one diagonal will be bisected and the other one will not be. That's a kite. A rhombus, all sides are the same length. We've studied rhombi. The diagonals are perpendicular, they bisect each other. A rhombus always ends up with 4 congruent right triangles. A kite ends up with 2 pairs of congruent right triangles. Whichever one you're doing, rhombus or kite, the formula is the area is equal to 1/2 diagonal 1 times the length of diagonal 2. Now, if you don't want to go that route and you just want to find the area of a triangle and multiply it by 4, that works. For a kite, you want to find the area of this triangle and double it, you get this other one. Then find the area of this triangle and double it and get this other one. But you got options, but these are the formulas generically. So what are the formulas that we've done so far for areas? We have a parallelogram, which is base times height. We have a trapezoid, which is 1/2 times the sum of the bases times the height. We have a triangle, which is half a parallelogram. We have kites and rhombi, which is half of diagonal 1 times diagonal 2. We have 4 more examples. Let's see if we can get through these fellas. Find the area of this rhombus. We know it's a rhombus because it says it's a rhombus. A rhombus always has diagonals that bisect each other, so that means this is also 20. It means this is also 30. Area of a rhombus is 1/2 diagonal 1 times diagonal 2. Diagonal 1 is 60. Sorry, diagonal 2 is 40. So that's half of 100. So the area of this, since the units were in feet, Picklesworth, I did fudge up. And sorry for the language, I just said fudge. The area is times. I started out with times, then I used plus, noob. When you're multiplying, you can multiply in any order. So half of 60 is 30. 30 times 40 is 120. Not 120. 1,200 is what I meant to say. Square feet. Let's check out the kite. Let's not do the kite yet. Let's do another rhombus. In order for us to find this area, we have to know the length of each diagonal. We know one of them is 16 because 8 plus 8 is going to be 16. Recall in a rhombus, the diagonals are perpendicular to each other. They bisect each other. That means this little fella right here is a right triangle, and not just any right triangle. It's a Pythagorean triple. It's a 6, 8, 10, which makes this whole diagonal 12. If you don't recognize it's a Pythagorean triple, use the Pythagorean theorem, and you would find that this still is going to be 6. Half of 16 is 8. 8 times 12 is 96. The units we're using is inches, so the area is 96 square inches. Let's check out this kite. Leave myself some room up there. Area of a kite is 1/2 diagonal 1 times diagonal 2. We know what diagonal 1 is. It's 20 and 20 because these are the same length, so that makes that 40. We don't know what the length of the diagonal is. We know part of it's 26, but we don't know the other part. What we can do is we can take this triangle right here, this right triangle, and we can use trig to try to figure out what this y value is. Using tangent of our acute angle, we are trying to find the opposite leg, and we know the length of the adjacent leg. That's why we use tangent. If you multiply both sides by 20, you're going to get 20 times tangent of 32 degrees is y. Put that in your calculator, you're going to get y is 12.5. Well, if that's 12.5, this other diagonal is going to be 26 plus 12.5, which is 28, 38.5. So the area is 1/2 times 40 times 38.5, which is 770 if I use my calculator correctly. And the units we were using here is square inches. Last one. So I hope you notice we are reviewing lots of things about triangles. Triangles are the foundation of all triangles. Write that down. We want to find the area of this little fella. It's 1/2 diagonal 1 times diagonal 2. We don't know the length of either diagonal. Well, that's frustrating. In case this is hard of reading, that's 18 right there. This is a 10. This is a 30. The diagonals of a kite are perpendicular. That makes this right triangle here a 30, 60, 90. If opposite 90 is 10, the short leg is half of that, which makes it 5. Opposite 60 is the short leg times the square root of 3. In a kite, one of the diagonals is bisected. That's going to be this one here. So the area is 1/2 diagonal 1, which would be 10 square roots of 3, times diagonal 2, 18 plus 5 is 23. Half of 18 is 5. 5 times 23 is 115. 115 square roots of 3 square centimeters is the exact area. If you wanted a rounded one, you throw that in your calculator and round her up. Up meaning round, not actually always round up. That's not what I meant. Alrighty, that concludes the notes of 16.3. Please do the homework. I'm sorry, 14.3. Please do the homework that accompanies it. Have a wonderful day.